Okay, there we go. Hello. Sorry to bring you inside on our first gorgeous day, but there will be many more of these types of days to come between now and the end of May. So rest assured. Let's see, I sent you all an email 25 minutes ago that says, forget it, I'm not going to, I could have dashed together a problem set and had lots of mistakes in it, decided that was not going to serve any of us well. So instead, the problem set, instead of being due a week from today, the problem set will be due, whatever that turned out to be, March 12th, I think was what the email said. So whatever the email said, the email was right. I will work on it today, tomorrow, or Saturday. There's a lot going on, so I'm not sure which day I'm going to do it. And post it online, and I'll send you an email when it's ready. So, but it's basically, it's going to be doing very similar things to what you did in the section exercise this week. So if you were good on the use of Excel in the section exercise, this will be straightforward. And if you struggled with Excel in the section exercise, the GSIs will be expecting you and your laptop in office hours. Okay. Oh, I forgot to plug in my little clicker. Strange start to the day. Oh, never turn your back on a crowd. You'll lose them immediately. I'm back. Look at all those donuts. No, thank you. But why do you have so many Krispy Kremes? You couldn't find enough. Are they supposed to buy them? How much? $1 a donut from him at the end of class. How many do you have left? Oh, it's economists. Supply and demand. How many donuts do you have left? It's $1 a donut either way. So it's a supply curve that is, which way is my supply curve? It's a horizontal supply curve. So perfectly priced, inelastic supply curve. So if you're willing to pay $1 or more for a Krispy Kreme donut, what kind of Krispy Kreme donut? Or does Krispy Kreme only make one kind of donut? They make multiple kinds. What kind of Krispy Kreme donuts? Just a normal glaze. Who are they going to benefit? A club on campus? Okay. Oh yes, if you want Girl Scout cookies, the Girl Scouts are all around $4 a box. If you want a Krispy Kreme glazed donut, you can get $1 a donut from, what's your name? Albert? From Albert at the end of class. So figure out your consumer surplus. All right, Girl Scout. Every spring on the first day when it's sunny and warm outside when class starts, it's really hard to get people to sort of focus in. Happens every year. It's cool. I understand it. But understanding it doesn't mean I forgive it. We're going to let it go. So here we go. Okay, get all out of your systems. We get all out. Okay, here we go. So I got some leftovers from Tuesday. I've got the banking stuff to do today. I pushed off the marketing and distribution until next Tuesday. So next Tuesday I'll do marketing and distribution and then education, and then immigration is next Thursday. Do y'all have any questions before I get started? Here we go. We talked about railroads on Tuesday. Where's Sam? Sam, are you here? There you are. The answer to your question. Sam asked me on Tuesday, why no railroads in the South, basically was the question. The answer has to do with the type of product. So the fact that cotton, once it's picked, it's put into bales. The bales work well in wagons. The value per bale was quite high. And so using wagons, even though the wagons were slower and could only transport one wagon worth of cotton at a time, it was still sufficiently profitable that there was no economic incentive to do a different transportation system. So it has to do with the type of product. So I was wrong about the rivers, but it has to do more with the type of product. So there you go. All right. The last piece we didn't get to about the railroad has to do with how much did the railroad contribute to the economy. So this is literature that comes under the heading of social savings. It's covered more fully in your textbook. I'm going to touch just on one piece of what's in the textbook, and that's the work that was done by Robert Fogel, work for which he received a Nobel Prize. So many moons ago, a long time ago, 30, 40 years ago, Bob Fogel asked the question, were railroads per se indispensable to U.S. economic growth? I mentioned this on the first day when I talked about the definition of the counterfactual. At the time that Fogel was doing this work in the late 60s, early 70s, the presumption amongst development economists, so people who were trying to improve living standards in third world countries, the presumption amongst development economists was that the construction and use of the railroad in the United States economy had been critical to economic growth, that the railroad both increased the K over L, capital to labor ratio in our growth equation, and also increased total factor productivity, the A in our growth equation, and that this combination of the increase in total factor productivity, the A in our equation, and the increase in the amount of capital, because those are expensive and large machines, was critical to boosting economic growth in the United States in the antebellum period, so particularly in the late 19th century after the Civil War. What Fogel set out to do was to see whether or not that was actually the case. Was it actually the case that the railroad per se was the thing that boosted growth, or could any transportation system have had the same effect? In a sense, it's sort of trying to tease out what were the contributions to A, total factor productivity, from the existence of a railroad that allows specialization in trade, as well as the movement of people across the country, from what were the contributions to GNP that came from what they would call backward linkages, from the building of those big steam engines and all the people who would be involved in that, plus then all of the demands for the inputs that go into the production of those steam engines. So it's sort of trying to tease out the K over L effect and the A effect of the railroads. As he did this work, the presumption was railroads. You got to have a railroad. If you want a third world country, name your poor third world country in 1968. If you want a third world country to grow, you got to build a railroad in that country. And Fogel wanted to say, do you have to have a railroad or do you have to have a transportation system? So what he did was he constructed a counterfactual. And his counterfactual, which was very extensive, and Bob Fogel was known for, still alive, I don't remember. If he's passed away, it's been in the last 5 years, and I don't remember. So he's either really, really old, or he's gone. One of the two. So what Fogel is or was known for, I'm not sure whether he is or was in that sentence, is doing really detailed, minute kind of work. And this first project was a real illustration of that, because he took and said, suppose instead of having a railroad system, suppose the United States had constructed a canal system and had built canals throughout the country and had used canals instead of railroads to transport goods and services. What would the effect have been on GDP, the total amount of output in the economy? And what he found was that we would have achieved the 1890 value of GDP at that point, essentially the same as the United States, total output per person, that we would have achieved the 1890 level of GNP per person just 2 years later. So yes, the railroad, as opposed to some other mode of transportation, did boost growth, that the level of GDP that we achieved in 1890 would have been delayed by 2 years if we hadn't had the railroad but had had a different transportation system instead. But 1890 versus 1892 is a very small difference. And so while the finding was, yes, the railroad did boost economic growth relative to any other transportation system, the boost was relatively small. And so the takeaway from this for development economists was that it's not a railroad per se that matters in terms of boosting economic growth. It's some sort of a transportation system. That transportation system can be roads, it can be canals, it can be railroads, it can be any kind of transportation system which makes sense for that place. And that the bulk of the benefit of the transportation system comes from the A, the total factor productivity, and not from the backward linkages of the steel and so on for building the railroad. Tell me your name one more time. Jackson. So the argument, the question is, when did it slow migration to the west? The argument is that the migration to the west, a lot of these people were not taking the train west. Some were who were coming here for gold, coming to California for gold, but those folks who were going on that Oklahoma land rush, they were on horses and with wagons. So a lot of the people who migrated west, because they're migrating their families, think about if you were to move across the country, you could fly across the country, but then you get 2 checked bags, $50 for the second checked bag, or you could drive across the country and you could pack your car full of stuff. Yeah. Okay. So this was the last piece. It would have made more sense if I'd done it on Tuesday. I was totally out of time and didn't have a chance. It's an important takeaway about the railroad that it's a transportation system that matters, that the reason we study the railroad is not because of the rails and the steam engines, but it's because the transportation system boosts economic growth through the ability to do specialization in trade. Okay. All right, turning the page. Away from railroads, and now we'll turn the page and look at industrialization. So, I just did that page. When we talk about industrialization, I really need to move these pieces of paper back and forth. Hold on. I'm organized backwards. There, that's better. When we look at industrialization, what we're going to look at is what happened. Again, we're doing the postbellum to World War II-ish period, so 1865-ish to 1920, 30-ish. And so here, table 3 from the handout for this week is looking at the distribution of total output. So look at total GDP. What are the sectors in the economy that are producing those goods and services? In 1869, this is not all of the sectors, so this does not add up to 100. So if you go column 1 plus column 2 plus column 3 plus column 4, it doesn't equal 100 because I omitted some of the categories. Okay, there's a total of 9 or 10 different categories. You didn't need to see all of them. Agriculture is around 20% of the economy throughout this period. So agriculture, how much does agriculture count in terms of GDP? 1869 through 1913, those numbers are all basically 20%. Today, the last year for which I got the data was 1997 when agriculture was 2% of the total. So the ag sector doesn't shrink as a share of the total. It stays about 20% throughout this period. Manufacturing throughout this period starts out 13% and then zooms up to about 20%. So we get some real increase in the share of manufacturing in the total, particularly 1880s to 1890s. So in the latter half of the 19th century, we're going to get a real uptick in the share of manufacturing. Transportation, 10-11% throughout that period. Trade, finance, and other services, around 40% throughout that entire period. There have been some substantial changes in these shares of total GDP over the post-World War II period. We'll talk about that in the third part of the course. But for the period that we're looking at now, we've got an economy that's about 20% ag, in terms of output, about 20% ag, about 20%, 15 to 20% manufacturing, about 40% services, and everything else. If we look instead at employment, if we look at employment instead, we see a different pattern. The patterns are different because of productivity growth. So agriculture is a pretty constant 20% of total output over this period, but as a share of the labor force, agriculture goes from being over 50% in 1870 to being 27% in 1920. That's reflecting huge gains in productivity in the agricultural sector. It just takes fewer people to produce the same amount of food. Because of the capital to labor substitution that we talked about just before the midterm when we looked at all those implements, how many people made brownies since then and used their plastic knife to cut them? And also because of the fertilizer revolution that I showed you the productivity, we didn't look at fertilizer per se. Manufacturing labor force goes from about 20% to about 26% by 1920. I need to update those bottom line numbers. The share of the population in manufacturing today, it's risen in recent years. We have a larger manufacturing sector today than we did in 2000, right before the bust. I think it's around 12 to 15%. Do we know this number? I don't know. I'll look it up before the third part of the course. Transportation is increasing. Trade, finance, services is about the same, around 25% of the population. So agriculture is shedding workers during this period. We don't need as many workers in agriculture. Where are those workers going? They're going into all sorts of things, but one of the places they're going into is manufacturing goods. So we're moving towards becoming a more industrialized nation over this latter half of the 19th century. When we talk about industrialization, we need to talk about the development of infrastructure and technology that allows, actually this is the definition, development of infrastructure and technology that allows an increased production of manufactured goods. So when economists say, oh yes, that's the period of industrialization, what do we mean? We mean that there is, hello? We're not seeing my computer on the screencast. Well, it doesn't matter because you guys aren't screencasting my computer anymore anyway, so. No, but I don't know. Are they screencasting still? They are still. Okay, good. Yeah, sure, fine. Yeah. But it's there. Y'all can see it, can't you? They can see it. Thanks for checking. Okay. Yep. No problem. There's just sometimes when you have some of those like weird days, when it's like, and then there was this guy who walked into my classroom who looked unlike anyone I'd ever seen at Berkeley before. I know I'm still being screencast, but truly, so the part of it was trying to figure out, wow, okay, this is not the ethics professor. It's not the computer sci guy or the physics guy. Okay. Okay, all right. It's just one of those days. All right, so development of infrastructure and technology in more clear terms. We've got a whole lot more machines that are using a whole lot of new ideas to run. And we've got a transportation system, that's part of the infrastructure, that allows these goods to get to market and to get to the customers relatively cheaply. So when we say development of infrastructure and technology that allows an increased production of manufactured goods, that's part of what we're talking about. We're also talking about mass production, the ability of companies to produce large quantities of goods. So an important piece of mass production, of course, was the interchangeable parts that we talked about previously. So when we talked about industrialization in the antebellum period, we talked about the importance of interchangeable parts, where you just reach into a bin and grab a screw. You don't have to get a particular handmade screw that goes in a particular handmade hole, that goes on a particular handmade bolt. One screw is just as good as another. So that interchangeability of parts is an important piece of the ability to do this large production, mass production of large quantities. But it's important to know that while we're talking about what's called continuous process production technology, which I'll come back and define in just a second, we're not talking about the moving assembly line. So the moving assembly line is that Henry Ford introduces in 1913 for the construction of cars, and which you have seen in that I Love Lucy episode where they're trying to get the chocolates into the box and they all go in their mouths instead. The moving assembly line is a particular way of setting up continuous process production technology, but it's not the only way. So continuous process production technology, get my definition nice and clear here, is you arrange the activity in the plant according to the stages of production. So I can't do this off the cuff for a machine, but I can do it for clothing because I've sewn lots of clothes, right? So the first thing you're going to do is you have the fabric, and then you're going to have the pattern, and then you're going to put the pattern on the fabric, and then you're going to cut the fabric according to the pattern, and then you're going to start sewing the pieces together, and then you're going to do the finished work. So what the continuous process production technology does is it figures out a way to organize the factory so that each of those different steps of the production process is taking place in one part of the factory, and that there's a logical way to then move the things from that part of the factory to the next part where step 2 takes place. So you get the, Dennis. No, so that's an important piece. Dennis asked, is one worker responsible for all those steps that I described? No, and that's important. So you'll have workers whose responsibility is to get the bolts of fabric and get them ready. You'll have other workers whose responsibility is to lay out the bolts of fabric. You'll have other workers whose responsibility is to get the pattern on the fabric and cut it. Once they're done with one step, they pass it on to somebody else who does the next step. Right. So there's not a creativity to the process, right? You're not creating a whole finished good. Yeah, what's your name? Robert. For the assembly line, instead of moving the items, no, instead of the, how do I say this? That the items are coming by you on a conveyor belt. Thank you, Rachel. They're coming by on a conveyor belt. Have you seen the I Love Lucy episode with the chocolates? Oh, shoot, I should have YouTubed it, huh? Yeah, well, we'll do that some other time. Huh? Well, but you have to see the I Love Lucy one with the chocolates, because there's nothing like seeing the I Love Lucy one with the chocolates. So the work is coming by you on a conveyor belt. Yeah, and you're standing in the same place all day long and getting pain in your back. Okay. The industrialization of the United States was labor saving and natural resource using. We had scarce labor, but we had plentiful natural resources. So we're a country that has lots of trees that you can burn to make heat, to make steam, to power machinery. We have lots of coal that you can use to burn the coal, to make heat, to boil the water, to make steam, to power the machinery. So the resources, the natural resources, were at the time relatively cheap. The workers were relatively expensive. And so you wind up with not just capital for labor substitution, but capital for labor substitution where the machinery is using up a lot of natural resources. One of the thought discoveries in trying to piece together explanations of the United States industrialization process versus, say, England or other countries' industrialization process was that when people looked at it simply as capital and labor as the only two inputs to the production process, they never got to the right conclusion. They couldn't quite get all of the data to mesh with the story when they were just trying to explain what was going on in the United States as a substitution of capital for labor. But when they added in the role of natural resources and recognized that it was substituting both natural resources and machinery for workers, then all of a sudden what happened in the United States made a lot of sense. So what we developed in the United States was we developed machineries that sucked power, right? That used a lot of power and a lot of resources because at the time we didn't have the environmental consciousness that we have in the 21st century. We didn't even have it for most of the 20th century, and we sure as heck didn't have that environmental consciousness in the 19th century. And so using non-renewable resources, nobody saw that. Nobody had the phrase non-renewable resources. Nobody worried about non-renewable resources. We just burned a lot of trees. Okay. So economics, how are we going to explain this with economics? We can go back to that equilibrium profit maximizing equation. So we know that in profit max, ignore that. That your profit-maximizing firm is going to choose to use a mix of resources such that the marginal product of capital divided by the price of the machine, the capital, will be equal to the marginal product of labor divided by the price of labor. And the piece that actually Gavin Wright, who wrote the article about slavery that was in your reader, added on was the marginal product of natural resources divided by the price of natural resources. And so having these three, recognizing these three inputs, capital, labor, and natural resources, not in terms of the number of acres, but in terms of the things that we can burn up to create heat, to create boiled water, to create steam, to run machinery. That businesses that are profit maximizing will use the combinations of capital, labor, and natural resources, so these ratios, the marginal product per unit price, are all equal. Well, remember one law, and then I'll give you one idea. So remember the law of diminishing returns. The law of diminishing returns tells us that as we increase the quantity of some input, holding all other inputs constant, what happens to the marginal product of that input? As we add more and more and more workers to the production process with no additional capital or natural resources, the additional product of each additional worker remains positive, but is getting less, smaller and smaller. So we're going to get a decrease in the marginal product of the input. So if we increase the quantity of the input, that decreases the marginal product of the input. Okay, that's the principle that we have to remember, and that's from the law of diminishing returns. And then the fact that we get is a dual fact. We get one, that there's an increase in the price of labor, so workers are becoming more expensive to business to hire, and two, a decrease in the price of natural resources. Well, I always want to put my hand over one of these things, but you can still see it. I bet you I can do something. Let me try something. I know I tried it the other day, but I have another idea. So ignore this for just a second. There we go. So ignore the natural resources for just a second. If the price of labor goes up, and we only have capital and labor as inputs to the production process, if the price of labor goes up, then the increase in the price of labor is in the denominator, is going to decrease this overall marginal product per unit price ratio. And in order to restore equilibrium in this equation, we either need to increase the marginal product of labor or decrease the marginal product of capital. Either of those two things will get those ratios back into equilibrium once the price of labor has gone up. Now use your law of diminishing returns. In order for there to be a higher marginal product of labor, do you want more workers or fewer workers? Marginal product of labor goes up if there are more workers or fewer workers? Fewer workers. So to increase the marginal product of labor, you want to have fewer workers. To decrease the marginal product of capital, you're going to have a lower marginal product of capital. Do you want more machines or fewer machines? Marginal product diminishes as the quantity of the input increases. So the need to have a higher marginal product of labor means you would have fewer workers. The need to have a lower marginal product of capital means you would have more capital. So the increase in the price of labor alone would lead to a substitution of capital for labor. In addition, I think this is going to work. Ha! Oh, God, am I clever. In addition, the price of natural resources is going down. So the decrease in the price of natural resources, that piece alone would be increasing this overall ratio, the marginal product of natural resources divided by the price of natural resources. And so if you want to once again restore equilibrium, if you want these three ratios to all be the same, with a lower price of natural resources, you need to have a lower marginal product of those natural resources to get back to equilibrium. Marginal product declines when the quantity of natural resources goes which way, up or down? Up. So that's once again using this law of diminishing returns. So we're going to increase the quantity of natural resources.